Hello, everyone. I'm John O'Loughlin. Welcome to McDuff Lives, and welcome to a special edition of McDuff Lives, where we get to introduce a good friend of our good friend Corky Goss, whose name is Bob Greenyer. Bob Greenyer, welcome, and thank you for joining us this morning here. And you are, I think, in Europe. Am I right?
I am, yes, I'm in the Czech Republic, the east of the Czech Republic right now. So thank you very much, John, for inviting me on, and thanks, Corky, for his never-ending enthusiasm in subjects and broad and intellectual.
Absolutely, yeah. And I'll warn you in advance. My background is history and government, politics, also music, but my brain kind of breaks down when we get into scientific jargon. So, so I'm hoping we can spend a little time uh, at a level at which I can understand. And I just say that in advance because from talking to many scientists and especially involved in the understanding of biology, virology, and what's going on in the so-called pandemic world, I've had to delve into that stuff, and it's frightening to me. It's hard for me to read those formulas and things. And I'm a guy that actually took college level physics. So, help me out as much as you can as we delve into this. Let's start, Bob, by a little introduction, if you don't mind. Your qualifications for talking about this stuff and your experience with it.
Well, firstly, I've been interested in energy forms since I was a young boy. I developed a system where my entire bedroom was run when I was younger than 10 off a series of mirror tiles reflecting onto one single solar panel, which is the only thing I could afford at the time, powering a battery, which I charged, and I had a fan and a light in the room that I ran my room off. So, and I built a solar system for the hotel swimming pool as a child and so forth. Grew up on a farm, and of course, in the farm we had these greenhouses, and to extend the season, we would have a paraffin burner and we would create greenhouse gas, i.e., plant food called carbon dioxide. And the byproduct was raising the temperature as well of the greenhouse so that then we could start the growing season earlier. So I kind of grew up with the environment and with thinking about the environment. And honestly, I bought into the whole green movement. It was kind of like the plan was hatched around my birth date in, I think it was Tanzania, where they came up with the whole, whatever it was back then, I think it was global warming, but it changed to global climate change as the temperature went down. They couldn't argue it any longer. And so it's just, as long as there's a change in the weather, which is what you're perfectly used to for 7 times a day in the UK, there's an excuse to say there's a problem with the weather. But I always say that we've been having a lot of weather recently. So I got fascinated with science. From the age of 5, I was given £5 by my mum to read a volume of the Encyclopedia Britannica. And the first question I had was, why are the elements on Earth where they are? So why do you have iron in the middle of the continent? And why do you have aluminium on subduction zones and things like that? And why, if it all rains down the heavy elements evenly from the cosmos, why do you have a great big lump of gold in South Africa? And why do you have a great big lump of gold in Australia? How is this even possible? And it took till, I think, probably 4 or 5 years into this volunteering process that I started in 2012 to actually have a plausible answer for why that is. And it isn't necessarily that it rained down from the cosmos. So I went on to do science to the extreme, and I did manufacturing engineering at university. It was a government program called Special Engineering Program. We actually did every course at the university: material science, physics, mathematics, psychology, business studies, accounting, and
And
literally.
this is in the UK.
Yeah, so
So where was the farm?
the farm was also in the UK. Yeah, so we had 20 acres. We had 4 acres under glass of tomatoes. We produced very many tons of tomatoes every week, and 16 acres of potatoes. And we also produced a lot of flowers. So I grew up with chickens and ducks and geese and growing things. In fact, I've just come from the garden where I've been planting some seeds with my children. just
Oh,
a few minutes before we started this call.
well, I'm in the middle of trying to get a vegetable garden going myself. Not very experienced at it, but I feel like it's time.
Don't give up, and it's one of the most satisfying things to see that seed germinate and to watch it slowly get up speed, and then it really gets going, and then you see the flowers and the fruit coming. It's one of the most satisfying things a human can do, and I expect a lot more people are going to be doing it as they get. There's a kind of a shift going on. I think there's this a kind of like psychological shift going on in the Western world where there's a desperate need for connection with real, right? As at the same time, everything's becoming artificial. And there's nothing more real than the smell of that dirt and the connection with the birds that want to eat the worms where you've just tilled the ground and stuff. It's a wonderful thing. So, yeah.
Oh,
So
I've got a whole supply of worms on its way right now. It's coming from Amazon. It's going to be wonderful. We're going to put it in the compost heap, and we're expecting great results from these worms. Yeah, actually, it was through Corky and a previous show that I got turned on to the idea of red worms enhancing the compost. We started the compost last fall, and it'd be great to have it being producing some good mulch for our hopeful vegetables. But anyway, it's beautiful here. Listen, as far as your background is concerned, have you ever do you have an expertise that you would say I'm an expert in this or that, or I'm a physicist, or I'm a biologist, or how would you characterize yourself as a scientist?
Well, I started out at SmithKline Beecham, which I think is Glaxo Wellcome now. I don't know; it's been merged so many times. But in their vaccine and antibiotic, uh,
Really?
yeah, their biggest factory in the UK, in my hometown of Worthing. And the reason I walked away from that after being there for 3 years was I sat at a table, and there was two or three, maybe four scientists on either side of the table, and some of them were vaccine producers, and some of them were antibiotics. And they said, "Bob, we don't have any profitable diseases to make cures for. We need to start making new diseases."
Uh-oh.
And at that time, there was some sort of thing in New Scientist that I was reading around that time, maybe, where they were trying to promote this idea that men had a period as well and needed to take a pill for,
Oh God.
I don't know if anyone remembers that, but I had that in my mind. I had
Oh,
these
it's not
people.
over yet, believe me.
So I threw up my hands, meant when you saw those old Ally McBeal episodes and there was kind of like an internal dialogue scene. Well, that's kind of what was going on in my head. I threw up my hands and stormed out of there. I said, I don't want to be a part of this. And I walked away from that industry. And I walked away from the advertising industry when they were handing out single cigarettes to children on the beaches in Africa. And I walked away from the banking industry when I found out they were facilitating loans in Iran to the tune of many, actually hundreds of billions, but they make a small margin on it in contravention of American sanctions. But the actual really egregious thing was that it just took the CEO to go to New York and write a check for $870 million. And it was like, all right, carry on. Because what they said is if you don't write a check, you can't trade in dollars. And that was 70% of their business. So it's a protection racket. You make a rule that countries have to fall foul of so international trade can move forward. And then they say, unless you pay us a big lump of money to the Southern District of New York or whatever it is, you will not be operating as a bank tomorrow, basically.
Sure.
So I learned in the advertising industry, in the banking industry, in the pharmaceutical industry, that there is a lot of go along to get along, and they're creating businesses where there shouldn't be businesses, and so on. So I thought,
Well,
like, if I'm gonna do something, I'm gonna have to do something where it has a good chance of a positive outcome, and I can use my talents, and I don't have to deal with these kind of moral issues, which I seem not to be able to cope with very well.
I had no idea you were associated with that GlaxoSmithKline or whatever their current name is, but that's a whole nother discussion.
It's a long time ago. It's a
That
long
we
time ago.
is it? Oh,
Yeah.
okay.
So
But
I was
nevertheless,
18 to 21, 18 to 21, and I'm 50 now. So um, Yeah, it was. I could have had a beautiful career
Okay, all
in
right.
each of those industries if I'd have just
Yeah.
played the ball and turned a blind eye, but I wasn't willing to do that.
Now, do you publish things?
I have, but mostly I publish in an non-conventional way for the field, which is through YouTube, actually, and through live streaming. And the reason I chose to do that is because I recognize that in the field, there were almost no one reading other people's papers. And if they did, they read the abstract and the conclusion at best. And so you get a typical paper and it might have a couple of hundred reads, whereas I can put out a YouTube video and it gets 1, 2, 3,000 views sometimes. And the difference is that the people that would read the paper are not interested in replicating your work or considering it in their own work. The people that are watching the video, they are the people that really want to make this happen. Now, they might not be capable of making it happen, but even what I found very early on in these various different industries was that people from all walks of life often have something to contribute, that they've seen something, they've read something, and so on. And they might just have the key that unlocks the whole puzzle. And so what I wanted to do with this process, I went to South Korea in 2012. There was a fairly controversial Italian called Andrea Rossi, and his work was published on a site called ECAP World. And he was basically revived what I was quite passionate about in 1989, this whole topic of so-called cold fusion. And I was interested enough to go and find out if there's any truth in it. So I self-financed myself to go to this conference. And what I realized was there were all these people actually getting quite senior, and some of them were passing away. In fact, Martin Fleischmann himself, after which the project is named, the Martin Fleischmann Memorial Project, he died 3 weeks before the conference, so I never actually got to meet him. But what was true was many people had the same observations, but in different systems. But there was about 130 different theories. And so at least 129 of them were wrong. So they can't all be right. And so, but the thing was, everyone wanted the Nobel Prize. Everyone wanted to reach that pinnacle of adulation. And the point is that they weren't replicating other people's work because they're not going to help someone else get the Nobel Prize by verifying them. And so we conceived of this project called the Martin Fleischmann Memorial Project with the aim of replicating people who were courageous enough to allow their technology to be independently verified by us, and we would do it in a novel way. And I conceived of this process of called live open science, where we showed what we wanted to do, the protocol, we showed the apparatus we were intending to use, and we then shared the data as the experiment was being conducted live and on the internet. It'd never been done like this before. In fact, it took years before National Instruments were able to do something similar. And the idea was that if something happened, it happened in a way that we couldn't fudge it. And it was all of the data that was made public. It wasn't just cherry-picked data. And one of the scientists, a scientist from the Italian Nuclear Frascati Institute, INFI, called Francesco Celani, he was courageous enough to have his technology tested with us. And that's what we did. And the first time we failed. And why did we fail? Because we thought we could add something new to it. And that is the fatal mistake of people replicating. And what it was is he said he was going to use a particular new type of glass called fused quartz. And we thought we would do that ahead of him. And it failed. Now, he was using a thing called borosilicate glass, the same kind of thing you will have in your IKEA glasses that you put your drinks in. Okay, it has boron in there. The fused quartz is only silicon and oxygen. So then, so we went back to the borosilicate glass, and on our second attempt, which was an experiment that we started at 12 seconds past 12 minutes past 12 on the 12th of the 12th of the 12th, California time, 2 days later, on the 14th of December 2012, we got 12.5% excess heat. And I presented that data at a military base in Rome on that day, 14th of December 2012. And from that point, I was ruined because I'd seen the excess heat. So now I had to explain it.
Okay, I'm going to go back and try to unpack some of what you said so that I can grasp onto it. First of all, you mentioned something. You mentioned, quote, the field. What is the field? Can you give me a short definition? What field are you working in?
Well, so in Szczecin, which is a place in Poland, they will be holding ICCF 25. Now, ICCF stands for International Cold Fusion, basically,
Okay.
International Conference on Cold Fusion. Okay, that's what it's always been called. The name Cold Fusion was assigned by one Stephen E. Jones to the work of Pons and Fleischmann. They were never comfortable with that, but it stuck, unfortunately. And so that's what it was called. Now they call it condensed matter nuclear science. And over the period of time, to get away from the word nuclear being in these phrases, people try all kinds of different ways of changing the nomenclature. But basically, it's cold fusion. So it was
Okay.
1989. Now, actually, apparently, there is a Russian in the 1950s that did palladium deuterium fusion boiling water reactor, but it was a classified, so you can't really give them credit. And it was Paneth Peters, I think, in the 1920s that did some work. But originally, it came from Thomas Graham, FRS, from the late 1876, I think it was, just a year before he died. He found that palladium absorbed the most hydrogen. So there's a lot of history in this. And then it was a question of, can we get the lightest element, hydrogen, or its isotope deuterium, which has an extra neutron? Can we get this to fuse into helium? And if so, we should gain a huge amount of energy. And that is the so-called, and can we do it at room temperature or without having to bash things together at millions of degrees, like they're doing, for instance, in ITER, in a tokamak? And so that's why it's given the name cold fusion. You start with light elements, you make a slightly heavier elements by combining them. And so that is where that came about.
Great. That gives me a handle on it. I see what you're saying now. Now I've got a hydrogen atom, and I want to turn it into a helium atom, right? Um, and what do you do? How do you introduce them? And
Now that's where the 130 theories come in,
okay,
right?
all right. But you said that you produced excess heat, and I suppose that is a signature of a positive result in that you've created,
It's a
you've
signature
released
of
you've released energy, correct?
it's a signature of something going on. Now, if the heat is as a result of any reaction, if you're getting heat out and something occurs, other than extracting the heat from the far field into the reactor, condensing it, and then passing it locally to where the heat is detected, okay? Sort of like, imagine like a heat pump takes heat from outside and it heats your house.
Yeah.
That's that concept. As long as it's not that and it's coming from a chemical or nuclear reaction, all energy, i.e., thermal photons in the IR range, or vibrations in a metal lattice or whatever, they're coming, if there's a source, they're coming from a change in the distortion of the physical vacuum. Now, that doesn't matter whether it's chemical or nuclear. And so if you can imagine, you have a deuteron and it occupies 1 unit of this physical vacuum, and you have another one and it occupies 1 unit of the physical vacuum. When you fuse those two together, you actually get something that's close approximation to 1 unit of the physical vacuum. And so that extra distortion that has been released comes out as energy. Okay. Now, it's actually almost the most per nucleon you can get is from fusing deuterium and deuterium. It's something like 25 million electron volts. So you divide that by 4 nucleons, you get what, 6 or something million electron volts. Put that in context, you're getting something like 5 electron volts when you take a carbon atom and you make CO2 by fusing 2 oxygens to it chemically. So 5 electron volts, nearly 6 million electron volts per nucleon. And if you add the nucleons in CO2, it's much, much lower. So it's a vastly higher amount of energy. If you're talking about fission going on, if you take uranium-235 and you split that into, let's say, something like cesium-137 and something else, right? Another fraction that's roughly half. Then you end up with something like 235 million electron volts. But you're starting with a large number of nucleons. So per nucleon, actually fusion gives you more energy per nucleon than does fission. Okay, it's just very, very hard to achieve historically.
What is a nucleon?
A nucleon is like a proton, which is the simple nucleus of an atom. That's the nucleus of a hydrogen, what's called protein. Deuterium is a proton with a neutron, which is what's called heavy hydrogen, and tritium is like super heavy hydrogen. It's got a proton with 2 neutrons. So all of those are a nucleon. That is the center of your atom with your electrons flying around the outside.
Okay. All right.
Now, in each case, they only have 1 electron. But if you go to helium, they have 2 protons. So for each proton, you need an electron matched in the shell structure around the atom. I say the nucleon is whatever's in the center. So uranium-235 has 235 nucleons in its nuclei, which is the center of the atom. A helium atom has 4 nucleons in its nuclei.
Mm-hmm.
And I don't know, say copper 63 or copper 65. They're the 2 natural isotopes of copper. They have 63 or 65 nucleons in their nuclei. So they're the little balls that make up the center of the nucleus of the atom.
I always understood that those were protons and neutrons.
Yeah, but protons and neutrons are nucleons. They're both nucleons. The protons and neutrons are a subset of nucleons, and then a group of them, which can be as little as 1 proton, can be a nuclei at the center of an atom.
Okay, let's get back to the big picture here. You're saying that you've been able to create energy from this fusion process that is far exceeds anything that's been done in other processes, including nuclear fission. So
I'm saying that what it was thought to be was fusion. Okay, that's what it was named in 1989, cold fusion. But with researchers like this, Takaaki Matsumoto, whose book here in 1991, here in Japanese, he found that it was effectively like the natural process of ball lightning, where electrons formed a construct that was able to use the electric force, which is 40 orders of magnitude larger than the gravitational force, to achieve something similar to what goes on in the sun or a black hole. And what he found was, in studying cold fusion from 1989, was that not only did you get fusion, you got fission, transmutation, and nucleon decay. And when you're talking about nucleon decay, you're not talking about 6 million electron volts per nucleon, right? As you're getting in the fission, you're talking about 930 or something over 900 million electron volts from the decay of, say, a proton decay.
Mm-hmm.
So this is unbelievably more energy than you can possibly imagine coming out of a chemical reaction.
All right.
So it's way beyond fusion.
Let me just clarify in my own mind, because you were talking about adding 2 deuterium atoms to each other and producing energy.
Yes.
Now you're talking about decaying a proton. That sounds like the opposite process? How does the proton get decayed, and is that part of your process of joining these 2 deuterium atoms together?
Actually, so some of the reactions that are observed in cold fusion could possibly be because when the process is decaying a proton, it fires out mesons and muons. These are other subparticles of these nuclei and nucleons. They're even smaller. They cause other nuclear reactions to occur. So the person, Stephen E. Jones, who I mentioned before, he was a proponent and one of the discoverers of muon catalyzed fusion. And muons are like a very heavy electron. And so if you had a deuterium atom with a heavy electron, it's much closer to the nucleus. And so when the nuclei come together of two deuteriums and they have a muon involved, they fuse. And there's various models called the liquid drop model. It doesn't matter. The point is that it's much more likely that they'll fuse than they'll ever fuse when you have electrons involved, because it's 207. The muon is 207 times the mass of the electron, so it orbits much closer to the actual nucleus of the deuterium atom. So that is something that can come out. So the muons can be made by the decay of the protons, and they can stimulate further nuclear reactions. So actually what goes on in these processes is a whole range of nuclear reactions, not just fusion. It's far, far more interesting. If I might read you the introduction to his book, it's very short, and we've made this free and available as a PDF. It says here, far in the universe, nuclear collapses very often take place by the gravitational force after stars consume their fuel. Since the electromagnetic force is about 40 orders stronger than the gravitational force, it should be easy to induce similar nuclear collapses by the electromagnetic force in the laboratory, but we never knew until now how to do that. Recently, and this was in the mid-1990s, the author discovered a nuclear collapse which was induced by the electromagnetic force in the laboratory during studying the mechanisms of so-called cold fusion phenomena. Several kinds of nuclear reaction were directly induced by the electromagnetic force, called electronuclear reactions, ENRs. They were so far found to occur in a special state of hydrogen clusters called itonic clusters. That is his theory. I can explain it later, but here's the kicker. Or micro ball lightning. Now, ball lightning is a natural phenomenon, okay? The nuclear collapse was one of the most remarkable reactions among electronuclear reactions, called the electronuclear collapse, ENC. Furthermore, and very amazingly, completely broken materials by electronuclear collapse were found to be regenerated again to thin tubes and films of conventional elements such as carbon, oxygen, and iron. The latter process was called electronuclear regeneration. And that really happens. We've replicated those phenomena, and it's really rather simple to do. It's almost laughably simple to do. So he proposes one experiment. It's a standard 120 volt AC electrode of lead, pure lead, 1 millimeter, in potassium hydroxide solution, 1 molar, I think, and then he has it in a copper box, and he does a few pulses of that electric energy, and he sees these spheres of lead, and out of the center of the spheres, from a pole, comes a plume of, let's say, carbon, the synthesized element, where there is no carbon in the experiment to begin with. And there's reasons why the carbon is formed. But what you are talking about here is the flower of life. This is the technology which will allow us to go to the heavens, get a planet where there's any matter at all, and convert that matter into everything we need to start life. We don't need a supernova. We don't need those technologies to do this. It's beautiful.
Well, I'm going to let that kind of ring for a second. It's beautiful. And so you are at the forefront of this research, along with the scientists that you refer to, and I hope that, as you say, you make them available on a website, I take it?
Yeah, so the first initial work we did was on quantumheat.org, and that is a website where we did most of the initial replications of the Chelani reactor and other work. We then have the Martin Fleischmann Memorial Project's YouTube channel, which is MFMP, and also there is a Twitter account associated and a Facebook account associated with that. And because of various censorship processes going on, I decided to switch tack and I published to Substack. Mm-hmm. And so that is where predominantly the work that I output goes to. So you can, and that is remoteview.icu is the blog where you can go and find the information out there. And the YouTube will tie back to there and so on and vice versa. And it'll refer to whatever source is the most appropriate at the time.
All right. Have the men in the black suits and black ties and shades come to see you yet?
Well, they don't appear like that. I have been prevented from speaking at conferences, and I found out through the back channel why that was and who prevented the speaking. I have had people writing to me and specifically threatening, and these are people who, at least one of them, like to promote the fact that they were a special executive service member, included their CV in the email. So I've had interrogations. I've been at conferences where I've had in a 1.5 day period, 3 people come up and stand in front of me and order me not to talk about certain subjects.
People came up to you and ordered you.
Yes, so do not talk about these things.
These people come from, are they just
Well,
miscellaneous
actually,
people?
some of them, they turn up at the conferences, but
Yeah.
they never seem to publish anything. Make of that what you will.
Well, what's the odds that somebody at some highly paid secret laboratory has figured all this stuff out 50 years ago, and they're suppressing it so that we all have to buy energy from the grid? Um,
Well, I would actually argue it was at least 70 years ago,
okay.
at least 65 years ago. So, for instance, there is some work that was done in the 1950s on piezo crystals, like this one here. This is a quartz crystal. It's the same type of thing as the fused quartz here that we have here, which has this Evo strike mark on it here from an experiment. You see that little toroid structure there. Okay. But this is a natural crystal. And when you compress this, it produces an electric field. Okay, and if you do that, compress it and decompress it, it'll then produce an electromagnetic field. Now, what some researchers did in the UK back in the 1950s is they took a magnetron, not this magnetron, this is one out of a microwave, right? And they put the magnetron in a chamber with a piece of quartz. And what they did is they did a couple of pulses on the magnetron, and then the piezo crystal converted the electromagnetic wave into a phonon. That is a sound vibration, but way above ultrasound. This is the frequency of vibration is at the frequency of the electromagnetic wave. And that went down the quartz crystal to the flat other polished end and bounced back partially. And as it bounced back, it would send out a little pulse of the electromagnetic wave it was fed in the pulse it received initially. But this would happen over a number of cycles of the speed of sound through the quartz crystal. Okay, and so this was very interesting to me when I read this paper, because I was trying to explain what John Hutchison had observed when he was using radio frequency interacting fields to, say, for instance, twist this piece of metal without it getting hot. Something had to be going on. And so when I went and saw the Hutchison lab in Germany, as it was, I think at the beginning of 2018, January 6, 2018, I sat with one Hutchison sample and I proposed that if you had a piezoelectric material on the surface of this, that what it said in this paper was that if you can get a 10, whatever it is, the old, so it's like 10 gigahertz, right? But there was old megacycles or whatever. But anyway, let's say 10 gigahertz. You start to get phonons, i.e. vibrations, that are at the frequency of the distance between the nucleus of the atoms. Okay. Now, if you imagine you get standing waves in that, and you get phase conjugation, right? You get the standing wave and the 180 degrees out of phase of that, you can end up with it's like cymatics, but on the individual atom level. You can force them to cohere. So I was saying that I think that this technology, if you had a piezoelectric material on the outside, then you could produce standing waves and end up with coherence. Well, the Salvatore Pais patents came out subsequent to my YouTube video when I was saying that. And they were saying that the US, is it Air Force or Navy? One of the two that Salvatore Pais is connected with. If they put PZT, which is one of the most effective piezoelectric materials known to man, on the outside of of an aluminium rod, and they gave it with a solenoid around the outside and gave it pulses, they could produce above room temperature superconductivity in the whole aluminium rod. And that is what I was arguing was going on. So my hypothesis, based off a paper that was published in 1963 from research that was done in the 1950s, would allow for superconducting above room temperature in aluminium. And then it comes out in a patent, which is awarded to the US government. Because that's what they have to do, and they can always backdate whatever they like. So my understanding in 2017 was that this is all probably done, and the only way to get it out the door is to publish it, and then they'll have to backdate from just before you publish the claim to give themselves precedent, and then they've got a 20-year window.
So it really is, as I was suspecting, a fight for suppression of a technology that probably could set us free from a great deal of economic enslavement that we all suffer from. This type of technology, if developed on a reasonable level, could just take away all of our need to burn.
100%. We did not need any of the wars in the last century.
Yeah.
The 1914 patent of Nikola Tesla, it was not an energy transmitter. It was using this technology. It had a D4D torus with plasma globes. They self-organize to make a fractal toroidal structure. This produces the Sothic triangle, which draws energy from the Earth out of the inside of matter, and it converts that into power that you can transmit.
Well, you just said something that I've been trying to understand for years. I buy books on Tesla and I don't get it. But
because no one in the West learnt what a guy called V. Dubovik had discovered in his thesis at Dubna, the nuclear research center 50 kilometers north of Moscow in 1965, called the toroidal moment. Now, it is in mainstream papers in Physics Review A and in Nature and stuff right now being discussed for next generation memory storage at the nanoscale. But Tesla was building this thing on the very, very macro scale. Now, whether he fully understood it is not sure, but you don't have to fully understand a process to be able to create something that gives you utility at the end. Lots of people don't understand how a lead acid accumulator battery works. Lots of people don't even understand how ignition works, and why should they? They just want to get on with their little window on life, pay the bills, have babies if that's their thing, and have a pleasant path to death without too many taxes and upsetting too many people. So
isn't that just? I mean, that's the times. That's what they've done to us with their propaganda. Is they've turned us into people that are completely satisfied to just survive at a reasonable comfort level, and that's it.
This planet can support trillions of people.
I'm sure of it. Yeah,
comfortably, without damaging the environment.
Of course, and all of those people are going to have brilliant ideas because their minds will be free from the necessity of incessant labor, and the universe will be ours.
The reality is, though, if you look at Tesla's 1911, I think it was it was a Sun New York article where he says, using this principle, I can make a flying machine that the likes of which the world has never seen. It'll have no control surfaces or screw propellers of any kind. It will be possibly of any shape, be of any weight, and travel at fantastic speeds, regardless of the weather conditions. Something like along those lines is what he wrote. And it took till the 1950s before they started producing the alien reproduction vehicle, which is based on this same principle. When you understand this principle, which is the toroidal moment and the fractal toroidal moment. Now, what do I mean by that? If you have electricity that runs through a wire, okay, you've got the right-hand rule or whatever it is. You've got magnetism that's associated with it and stuff, okay? But the pointing vector comes off, which is kind of like the expression of the energy, comes off and dissipates. If you put it in a loop, okay, then the pointing vector comes off and dissipates. If you put it in a spiral, the pointing vector comes off and dissipates. If you put it into a loop of a spiral. So if you take a solenoid, which is like a spiral, and rather than just have it a long spiral, you just wrap that round, you end up with the first toroidal moment. And it's not an electric field or a magnetic field. It's a toroidal moment. It is physically different the way it works. Okay. And if you take a coil of a coil of a coil, you end up with a Poynting vector that doesn't dissipate. It folds back on itself, and you can energize a piece of space and end up with what's called a vacuum current. And if you take a coil of a coil of a coil of a coil, you can end up with a Poynting vector that folds in on itself, and one at 90 degrees. And if one collapses, it energizes the other. And you can energize a piece of space, and that energy will persist there when you turn off the power and move the thing that made it away from it. It's an electromagnetic phantom. And the Soviets were studying this as part of their energetics research during the Cold War.
You know, just the fact that you can explain it to me means that this stuff is not beyond the capacity.
No. This is so simple. It's the amount of effort that must have gone into. Firstly, it protects itself by its sheer unbelievability, right? Then there is an unbelievable amount of effort to make sure that this doesn't see the light of day. I call it the God's toolbox for a very good reason. There's almost nothing, as Ken Shoulders, who was a very principled person in studying John's work and deducing to a degree what John had done to achieve his effects. That's John Hutchison. He said that if there's something you would want to do well, this is probably the technology that does it. And it doesn't matter. It doesn't matter whether it's propulsion. You don't need anti-gravity if you've got propulsion, because propulsion works everywhere. Anti-gravity, you need a gravitational body to push off or resist, if you know what I mean. So propulsion's much more important. And transmutation does that nicely, very, very easily. The Coulomb barrier is not an issue for this process. It's not an issue. See, what happens with the vacuum current is you get to a point, and there's a guy called David Freiberger from SLAC in California, from the Stanford Linear Accelerator. He was looking at some things that were seen in another national lab where they had a superconducting chamber and these little balls of light were going around. They couldn't explain it. Well, this guy called David Freiberger from SLAC, he was an expert in this field of ball lightning, and he did a study in 2009, and he worked out that when you have this coil of a coil of a coil of a coil, or a coil of a coil of a coil, you end up with this thing called what's called a diality angle. That's his name for it. Doesn't really matter. But when that diality angle goes over a threshold, all matter collapses. It literally, according to his phrase, he says the nucleons fall off the grid of the Dirac Sea, and they just fall apart. They become unstable and they just fall apart. That's his view of things. But the Russians had done this 21 years before. And that's the fractal toroidal moment. They're so far ahead, it's laughable, actually. It's embarrassing.
Would you mind explaining what plasma is and whether that has any relevance to what you're talking about?
It's very relevant.
I've been struggling with that too. Do you remember the Foo Fighters from World War II?
Yeah, they are probably this technology embodied.
So yeah, please start there and tell me, my instincts are that you're talking almost about plasma.
So plasma is where the fourth state of matter, supposedly, where you haven't got you got a solid, then you've got a liquid, then you've got a gas, and then you've got a plasma. What is a plasma? Well, plasma is where the atoms are at least partially ionized, i.e., you've got some of the electrons have been knocked off, normally energetically by thermal or by laser or by some other means of exciting them. You go through their ionization energy, and one or more electrons comes off. Okay, fully ionized atoms, very interestingly, like thallium-205, will decay when they are perfectly stable to the end of time, when they have all their electrons. And there are several atoms that have been proven to do this. So you can actually cause transmutation by removing all of the electrons. That is proven 100%. Right? So that's not happening in a star. That's already known that can happen. Okay, and it goes to lead 205, and that actually decays back to thallium 205. So it's actually a reversible process. Okay, but so plasma is this separation, but Tesla found something slightly different. He found that when he was doing a unidirectional disruptive discharge, that is a very high, fast rise time, high energy pulse between a spark gap, that he would see these emissions that would give him a prick in his body, and he would, ow, that's really painful. So he would send him, go back like 15 feet or whatever from his apparatus, and he would stand behind a metal shield, and ow, he was still getting them. And then he would put a insulator like quartz or something in there, and ow, he was still getting them. What was going on that these things could fly vast distances through space, through the air at atmospheric pressure, go through metal or quartz, and still give him painful shocks? Something very odd was going on. And what he found is that this thing called etheric matter streams. And what these are is not the electrons or the ionized atom. It's something different. Okay, and the only way you get pure etheric matter streams in his experiments was to use magnesium, our friend aluminium, or beryllium. Why? Because they are light elements. Now, he didn't study things like lithium, and he didn't study hydrogen in this because they're not a solid target, are they? Well, lithium is, but hydrogen isn't a solid target. So he was looking at solid targets that he could readily get readily available. There's a group called who works with Dubovik, who is still alive, who worked out the toroidal moment, called Alexander Shishkin. And these scientists are all in their 80s. But they've worked out that hydrogen isotopes can be charge separated in this way, and it's full charge separation. It's not just making a plasma, it's going beyond that, where you have what they call the shell of the atom, which is a neutral toroidal structure, which is a cluster of relic neutrinos. I'll explain what relic neutrinos are in a little while, but there's three things that you get, and that is the etheric matter. And this is the etheric matter streams that Tesla was able to fire through a wall, X-ray himself, and then they were caught by a zinc sulfide phosphor screen. Okay, because these things interact with the photosites on zinc sulfide. Okay, so
are you talking about something that is physical, or something that is simply electrical energy, or something in between?
Something in between. So what these are they are mass. They do have mass. They are so at the birth of the universe, if you believe in the Big Bang, it's not necessary to believe in the Big Bang for this to be true also, because if you believe that the universe goes on a cycle and there are individual subcycles going on in different parts of the universe, the theory still holds true, right? But there's this matter called dark matter, and there's dark energy. And a component of that dark matter, but maybe as much as, I think it's 3%. I'll have to check. I have Parkamov's book here in Russian. I have given away all the ones that are in English. I translated this from Russian with a philologist from Ukraine some years ago. But all of the luminous matter in the universe is not as much as just the relic neutrino, dark matter. Okay, and this is available as a single temperature coherent condensate through the entire universe. This technology is able to provide energy at any point in the universe if you can access it. Now, the understanding is that it is able to be interacted with using the toroidal moment. So if you interact with it with the toroidal moment, you can condense it, and you can convert the energy that's within it into real work. In normal matter, you have the electrons held around the nucleus by a cluster of this stuff that's ordinarily in a condensate in the universe. And what Shishkin has this thing where he says, what is the atom battery? Like, why does the electrons keep spinning on an atom? You know, if there's no perpetuum mobile, how do you How do you have atoms continually keeping their electrons alive? Well, the theory goes something like this. This shell has this field that pulls in these relic neutrinos that pervade the universe. They go through everything and so on, but they do interact weakly with ordinary matter. And they have their own amount of energy. They go in through one pole, and it extracts a minute amount of energy if it's underpowered, or it sheds through the outside of this structure to the coherent condensate some energy. In this case, it has an input and output, and it maintains stability. That's what an atom normally does. And when you do proper ionization, that Tesla was doing, you punch it. You punch out the nuclei, the electrons come off, and you have these shells. And this is one thing that's called strange radiation, okay? Because it can actually capture other atoms along with it and transport it even through other matter. It becomes able to teleport matter through other metals and things like that. It's very, very weird stuff. But what they found is that to get this matter, if you start with hydrogen, it's 2,000 to 4,000 times easier than any element above lithium. Okay, so lithium is somewhere in between. But this is why these technologies that use these light elements, when you get them right, could possibly be delivering something that appears like magic, because it's so hard to do it with other elements. And what Tesla found was if he used heavy elements, then he just got what he called dirty etheric matter, where it's not a pure, fully charged, separated piece of matter. And he would end up with these pinpricks in these painful things. And it's good that he didn't do that, because when these things explode, they can shoot out the ions, the nuclei that they've captured and teleported, at speeds that are sufficient to destroy a red blood cell and cause DNA damage to a white blood cell. And thirdly, the actual neutrino clusters themselves, these relic neutrino clusters, they can interact with carbon-14, which is one in every trillion atom in your DNA sugars that hold your DNA together, and it can cause you to have cancer. And so several scientists in this field have died of cancer, and there's no real explanation for why. Of course, they're not young people, so cancer will probably get everyone sooner or later. But it's as well to realize that there is something that can be produced by this type of experimentation that has a danger. And they've developed a shield to protect against it. And do you know what the shield is? It's using a phosphor like Tesla used in the 1800s for showing this etheric matter stream, zinc sulfide or strontium aluminate. So you can shield against these things, and you use silver powder as an exciter, because it has a lot of free electrons, and you put it in a rubber base, so you can paint it onto your reactors. So it's very different. So we're not just talking about plasma; we're talking about a whole other thing that can be produced by these processes. And these things can cluster, and when they cluster, they're actually static electricity. That is what it is. So if you want to produce the thing that does the work in this technology, rub yourself on a carpet with some nylon or whatever on your shirt or whatever, and produce a spark from your finger. And every spark has one of these exotic vacuum objects, as Ken Shoulders called it, at the head of it. It's actually what causes the ionization channel in lightning. It's literally ubiquitous. It's all around us. We live with this thing. We evolve with this thing. It's actually part of the fundamental way nature works.
Well, this has been really enlightening for me. If that's not a good pun, I apologize, but it's really has been. And I'll tell you, in the last minute I've got, I'm just going to repeat to you what I thought of maybe 10 years ago. And as a musician, I started becoming aware of we used to call them piezo, but piezo in Italian, the piezo effect, which really converts mechanical energy into electrical energy is the way I understand it. And that's how our pickups work on our electric guitars and things like dynamic microphones and stuff that has the same type of technology. And I thought, well, why don't I just get a big warehouse? And in that warehouse, I'm going to hang a whole bunch of tubular bells, like a tubular bell,
Yep.
Right. and I'm going to take one of them and hit it with a hammer, but there's 1,000 more of them hanging from the ceiling, and they're all going to start resonating to the same, because it's sympathetic resonance, right? And they're
Hmm.
all going to start resonating, and then I'm going to put some piezos on the top of these guys so that when they do their thing, that it converts that mechanical energy into electrical energy, and then I can run my house with this warehouse with all these chimes hanging from the ceiling. Am I right?
Well, if you can get something, if you can get something in the environment to vibrate those tubular bells, i.e., the bells are resonant to a natural force that is otherwise underutilized, and then convert that energy into electric power, yes, you can power your house.
But hitting
Ordinary,
it with a hammer myself is cheating, right?
but no, no, well, no, that's still conversion. But you're providing the energy. You have to get your energy from somewhere.
Okay.
So so there is that. But there are people that are claiming to create neutrino cells, i.e., these are like solar cells, but they interact with neutrinos that are raining down from the cosmos, and they are converting that into electricity. So there is I have a book here by Constantin Mail, for instance, called Neutrino Power, that talks just about this. So you have the neutrino coming in, it goes through the conversion and comes out as an electron, or rather, it's not quite. It's not quite like that, but that's what they're saying. They don't consider relic neutrinos, which is a shame. So if you can use something that's underutilized, then yes, you can do that. And that's what I was talking about. This is piezo. So
Yeah.
is PZT. The simplest experiment you could do, and I ask your readers to go and look this up, is called the Ultra experiment. It uses a PZT, piezo transducer, the same type you would have on your guitar or other instruments, or even possibly in your microphone that you're speaking on through now, if it's not a cardioid. And so those things convert it into electricity. Well, it does it the other way. Electric power is put in at 43 kilohertz. You use a piece of plastic, a cake box, from a 10 CD or CDR tray. You then put aluminium foil over it, fill it up with water, and do you know what it produces? In seconds, it produces perfect yin yang structures. And on one side, it would appear heavier elements are synthesized, and on the other center, lighter elements are synthesized. And it's the easiest experiment. It can be done from 3 years and up. I think you need to be 5 years. You can learn how to do the experiment in about 7 minutes, and within 20 minutes, you've got observable results. If you've got a scanning electron microscope, you can start to see how the coherent matter interacts with the aluminium foil, or aluminum for you guys on that side of the pond, and you can see transmutations on the metal sample.
Well, Bob, this has been delightful for me. I've been trying for some years now to understand this stuff, and you've really whetted my appetite, which was my goal this morning. I knew I wasn't going to be able to wrap my arms around all of your great work, but at the same time, I do feel like I've gotten a start into it.
You
And
think you're on the right lines with the means of converting one form of energy into another. That's essentially what the process is doing.
fabulous. All right. So for further investigation, folks, get in touch with Bob Greenyer at his Substack, or however else you would like to. What's the name of the Substack once again, Bob?
It's remote view, all one word, dot letters ICU. So remoteview.icu.
Got it. Okay. Bob Greenyer, been a real pleasure. Thanks everybody for being with us, and we will see you tomorrow morning with Harley Schlanger. Thanks for joining my Rumble, folks. I really do appreciate it, as we're trying to get away from YouTube. Thanks again. Bye now.
Thanks, John.
And thank you, Bob. Really fun. Enjoyed it.
Sorry, I know it's a